Okay? All right, so the next one is a contingency table problem, but this time you need to make your own contingency table. It says pollsters are concerned about declining levels of cooperation among people contacted in surveys. A pollster contacted 200 people in the 18 to 21 age bracket and records whether or not they respond or refuse to respond. She finds 42% respond. When 400 people in the 22 to 29 age bracket are contacted, 75% respond. So we're going to make a contingency table for this. Now, again, it really doesn't matter what you use as your rows and columns. So if your instinct was to do something different, that's okay. But you would have respond and refuse to respond. Those are my two categories. Okay, and then I have my two age groups, the 18 to 21, the 22 to 29, and then I'm going to have my total, and I'll have a total here as well. And then really I'm just going to start filling in the information that I know. So it says, pollsters are compliant, they contacted 200 people in the 18 to 21 age bracket. So we had 200 people in the 18 to 21 age bracket. Okay? And then 400 people in the 22 to 29. So we know our total is 600. Okay? So those are the easy ones. Now, when we look at that 200, it says she finds 42% of people in the 18 to 21 age bracket respond. So we're going to take 42% of 200. Okay, that's 84. All right, which means this must be 116. Okay, and then it says that 75% of people in this age bracket respond. That's 75% of 400, which is 300. Which means this is 100. And then again, we can add across. That's 384, and that's 216. Okay, so there's our contingency table. Again, you're definitely going to have to make one. Now we're going to answer some questions based on the contingency table that we made. So it says, what is the probability a randomly chosen person from the study is someone in the 18 to 29 age bracket or someone who refused to respond? If you remember, I said when we're talking about contingency tables, you're going to have a subtraction in that or problem. So first we look at what's the probability someone's in the 22 to 29 age bracket. Well, there's 400 of them out of 600. Okay? Then we look at what's the probability of someone refusing to respond. There's 216 of them out of 600. Okay, but here, where we have the overlap, the refuse to respond, and in that age bracket, we've counted that twice because we added it here and we added it here, so we're going to subtract it. And that is equal to 516 over 600, which is equal to 43 over 50. Okay? The next question says, what is the probability that a randomly chosen person from the study is someone in the 18 to 29 age bracket and someone who refuses to respond? So even though this is an and problem, when you're using a contingency table, you are not going to multiply. You are just going to look and pull the number right out. So we want to look someone in the 18 to 21 and someone who refuses to respond. There's the 116. Okay, don't make the mistake. It's not 116 out of 200. That would have to be a given problem. Okay, this is just in general because it says probability someone in the study. How many people in the study? There's 600. So it's 116 out of 600, which is 29 out of 150. Okay, so again, an and you're just going to pull it out. What is the probability a randomly chosen person from the study is in the 18 to 29 age bracket given that they refuse to respond? Here's where that given problem. What am I given? I'm given that they refuse to respond. So I'm only talking about the people who refuse to respond. So my denominator is 216. Okay? Out of those 216, how many were in the 18 to 21 age bracket? That's 116. So it's 116 out of 216, which is 29 over 54.